Thank you very much, Mark, for inviting me to come here to talk about renewable and sustainable energy. Now, I'm actually a full-time YouTuber. Believe it or not, I've actually been doing that for 8 years. I'm actually an engineer, an electronics design engineer, and I run an engineering YouTube channel. And I do actually make videos on solar and renewable energy as well. So check out my website if you want to have a look at that. And I'm sure I've given talks at schools before, and everyone wants to know about being a full-time YouTuber. So maybe if there's enough time for Q&As at the end, I will take questions on being a full-time YouTuber, because I am living the dream. Anyway, we're here to talk about renewable and sustainable energy. So let's get into it. Why do we need renewable and sustainable energy? Well, it has to do with the hideous amount of energy that we use, and the fact that fossil fuels, I'm sure you all know what fossil fuels are, and we'll get into those, but they are incredibly polluting. We're pretty much destroying this planet due to our crazy appetite for energy consumption. It's nuts. Anyway, fossil fuels, they release carbon dioxide, which of course contributes to global warming, and sulfur dioxide, which is acid rain. And ironically, the sulfur dioxide actually helps cool down the atmosphere, but not enough to actually compensate for the CO2 that causes the global warming. Mercury, arsenic, horrible stuff, and particulate matter, all that smog that goes into the air that you can see in the photo here. Absolutely horrible. We're just polluting the air that we breathe, polluting the planet. So anyway, can anyone tell me what are the three main fossil fuels? Coal, yes. Gas, yes. Oil. And here's where we look at the huge amount, insane amount of energy that we actually use. We use coal. We use 21 million tons of coal per day. That's not per year, per day. So imagine the size of a small car weighs like a ton. We go through that amount of 21 million of those per day just to power all of our stupid electronics that we've got. And gas, we use 10 billion cubic meters of gas every single day. We're just burning that stuff to heat up our water and generate some electricity in gas-fired power plants and things like that. And oil, we love our oil. We start wars over oil. 43 million liters per day. Absolutely crazy. So more than 80% of our energy comes from these three fossil fuels. So obviously, if they're polluting and they're non-sustainable and we're taking 80%, why would we keep on using them? We're pretty stupid, us humans. Anyway, PewDiePie. Yes, I had to include PewDiePie. Sorry, there's a reason I'm including PewDiePie, because just to give you a sense for how much energy you use that you may not be aware of. Watching online video, online video streaming accounts for 300 million tons of CO2 per year. It's almost like 1% of our world's energy consumption is just used for like streaming video. This is because it's not just the amount of energy that your computer uses, it's all the server infrastructure. You don't realize this, but when you watch a streaming video, there's all the hundreds of servers, thousands of servers out there that have to work and generate all this video, and they take massive amounts of energy to run all this online video. Of course, we can't live in a modern world, and we probably wouldn't want to live in a modern world without all of our modern internet infrastructure and streaming video and our information revolution and all that sort of stuff. That's fine, but just be aware that watching 1 hour of PewDiePie a week uses more energy than 2 refrigerators, and the refrigerator is generally the most power consuming appliance in our house. But watching that video, even if you've got a nice eco-friendly low power TV or a laptop, or you're watching on your phone, it's still got to be streamed. So let's take a brief look at oil and gas. I actually used to work designing in the oil and gas survey industry. I used to design, see these little yellow streamers down here. I used to design these. This is how we search for oil and gas. They've got these giant, the ones out at sea anyway. You're familiar with the oil wells. Well, these giant seismic survey vessels, they're called, and they tow behind them. You can see the little, hopefully see those yellow streamers, like a dozen of these streamers. They're like, 5 or 8 kilometers long. They tow them behind the boat, and the boats just trawl around the oceans like this, and they've got these gigantic air gun arrays on them, which just go pow in the water, generate these massive acoustic impulses, which then travel down to the seafloor, penetrate the seafloor, and reflect back out, and they're actually picked up by these streamers, which contain thousands of these underwater microphones called hydrophones, and they pick up the sound, and then we can process that sort of data and figure out where the oil and gas pockets are under the ocean. So yeah, it's and then that's just finding it. That's not drilling it and then refining it. It's crazy expensive and crazy hard to find, drill, and refine oil. And by the way, these massive, you want to know how they used to do it? By the way, small little tangent, instead of these big air gun arrays, they actually used to just light up dynamite, toss it off the back end of the boat, boom! And of course, these air guns are horrible for whales, dolphins. They just hate it. They let these air guns off and the whales just go, "Ugh!" It's terrible. Anyway, and next time you're at the petrol station, you hear someone complaining, oh, $1.50 for a litre of petrol, $1.80, you gotta be kidding me, that's so expensive. Just slap them over the side of the head, please. Because oil and gas, this stuff took millions, tens of millions of years to produce. It's non-renewable. It takes countless resources and energy to find, produce it, refine it, and get it to that petrol pump. And then it's cheaper than the bottled water you can buy in that service station. Oil's expensive, my butt. Anyway, coal. Coal is a big deal. This is the Bulga coal mine near Singleton, and it produces 12 million tons of coal a year. So we need over 700 of these mines worldwide working 24/7 to produce the coal we need to generate the power that we require. It's just nuts. Anyway, very destructive. So that little piece of coal that you've got, the reason that we use coal and oil and gas is because they're very high energy density. So if you compare that little 10-gram lump of coal that you've got there to, say, the lithium-ion battery inside your phone, that little bit of coal could actually power your mobile, that 10 grams could power your mobile phone for more than a month. It's absolutely crazy. And then if you want to talk nuclear power, a 10-gram lump of uranium, when it's processed, a reactor-grade uranium, that could power your phone for 200,000 years. So yeah, very energy dense. That's why people just love to burn these things, because you dig them out of the ground, you burn them, and it generates power. And we won't get too much into nuclear, because nuclear is weird. It's not a fossil fuel. It's actually what's called a geological fuel, because it wasn't produced by fossils, like compressing like organic matter down over millions of years and then forming the carbon. So it's not that. It's actually inherent in the rock when our planet was formed. The energy's there, and we just simply refine that into reactor grade fuel, and then it's actually quite clean. So once you actually after you mine it and everything, it's actually quite clean. But anyway, let's not go there, because it's not really a fossil fuel. It's not a renewable fuel. And of course, uranium mining is a big thing, right? Australia is one of the leading uranium miners in the world. But it produces 1/100th the carbon dioxide emissions of coal. So nuclear is pretty clean compared to coal. So it's not bad, but it's not a renewable energy source. So let's look at sustainable renewable energy. If you have a look at the world's energy consumption, you can see about 32% comes from oil. So, and this is just energy. This is not electricity. This is overall energy. Power your car uses energy. Doesn't need electricity, needs energy. Oil is 32%. Coal about 28%, gas about 21%, renewables are only about 13%. So not a huge amount. Now, the almost 5% in there, that's nuclear. So yeah, so as I said, over 80% of our energy comes from these non-renewable fossil fuels. So Can anyone tell me what are the different types of renewable energy? Anyone? Bueller? Bueller? Now, the kind of definition of renewable energy is that it can be replenished on a human time scale, so to speak. So the sun is a big nuclear fireball, so technically the sun is not renewable, but we call wind but we call solar energy renewable energy, because once you've produced it, it just keeps manufacturing electricity. Once you put the energy to produce the solar panel, it just continues to produce the energy until it physically fails. So what we've got here, what this photo is, this is actually a solar thermal plant. So these are actually mirrors that reflect and focus the sun up to a big molten salt, a big lump of molten salt at the top, which stores the energy in this salt and heats up, and then they can pump water through it and turn a turbine and generate electricity that way. And that has big promise. So that's solar thermal, but that's not, it's not hugely popular these days. Of course, the most popular is wind and solar at the moment, but also got hydro as well. Hydro is pretty popular. There's lots of hydro plants here. We have the Snowy Hydro river scheme. The electricity that's powering this room at the moment could, in all likelihood, come from a hydro scheme. But of course, there's big environmental damage to actually creating the dams required for hydro. But once you've done that, hydro is pretty cool, actually. There's geothermal, of course, using the Earth's heat from within inside the Earth to generate electricity. Biomass, biofuel. That's interesting. Biomass and biofuel are basically where you take just organic waste products like wood and other types of stuff that we're just throwing away, and then you can heat that, you can burn that, and actually produce energy by burning that. So biomass, biofuels are pretty good, actually. There's quite a significant amount of energy produced worldwide by biofuels. And then, of course, we've got hydrogen fuel cells. A lot of people, especially like a decade ago, thought this was the future, and it may be, but unfortunately, hydrogen-powered cars and things like that, you need to put in a lot of energy to actually compress the hydrogen gas. You need to put a lot of energy in the first place in order for it to be useful, and then it's quite dangerous. It almost turns into a bomb, really. It's not a hydrogen bomb, but it is quite dangerous. So a lot of energy to compress that. So in theory, you could use like solar energy or other renewable energy to then compress the hydrogen, which then becomes a storage system for renewable energy. So there's some promise in there, and there's lots of research going on and stuff like that. But anyway, lots of different types of renewable energy. Some of them are incredibly popular, incredibly sexy at the moment. Others aren't. So you've got to remember, though, that renewable energy is not clean. It's not 100% clean. It's just cleaner than the fossil fuels. Because take, for example, this is a silica mine, okay? So you have to mine this silica, massive mines, to produce the silicon solar panels plus the glass that goes into making these solar panels. It's not free in terms of energy to manufacture these solar panels. That's why everyone talks about a payback period for solar panels, because it just takes a fairly significant amount of energy to produce those solar panels. But once you've produced them, then they continue to provide free, clean energy, until they fail for, 15, 20 years, something like that is a typical life of them. And then you've got the aluminium frames, which go around there. You've got aluminium mines, heavily energy intensive process to produce aluminium. So yeah, that's a big deal. So it doesn't come for free. There's no free lunch, unfortunately. Now, this rather complicated graph here, this is the world primary energy consumption from the 1950s through to the 2050s. So this predicts where the energy is going. So you can see at 2020, about where we are now, we're looking at, those three big fossil fuels, coal, oil, and gas, dominate the energy supply. And those ones at the top there, we're talking hydro, renewable, wind, and solar up there. And you'll notice that after 2020, the only one that spreads and gets bigger percentage, the only area that is growing is renewable energy. Coal is going to shrink, gas is going to shrink, oil is going to shrink. It's not going to shrink to zero, of course. We're always going to be using them. Unfortunately, there's no, at least in the foreseeable future, there's no utopia where we're 100% renewable worldwide. You have to be realistic about this sort of stuff. But the only growing industry there is wind, solar, and renewable. So if you're looking for jobs in the future, and let's get into that, careers. I just picked out a few jobs here, but there are hundreds and hundreds of different jobs in the solar and renewable energy industry. Really valuable, fulfilling careers here. Engineers like myself, we need power engineers, electronics engineers, that's me. We need computer engineers, software engineers, mechanical engineers, civil engineers, chemical engineers, automotive engineers, agricultural engineers, geologists, automation, materials, telecoms, production, test. For example, you might say, why do we need telecoms engineers, telecommunications engineers? Well, all these power plants and all these power grid infrastructure, for those who don't know, the grid, the power generating grid is the largest man-made object, is the largest man-made structure on Earth, is the electricity grid. And tying all those grids together without them synchronizing them all up, transferring energy between states, between countries, between the power plants and the load is an incredibly complex thing, and it requires lots of communications and other control infrastructure to actually do that. So it's a hideously complex thing. So that's just in the engineering field alone, there's dozens and dozens of different specialties. Absolutely amazing. So yeah, the engineer says you should become an engineer. So, and then scientists, of course, we need some of the big engineers do practical solutions to practical problems, but to really do the massive big step innovations, they're the scientists and the physicists. So we need theoretical physicists who are going to crack solar fusion. Fusion, for example, is 20 years away, but they've been saying that every 20 years for the last 60 years or something. That's the joke in the industry. Fusion's always 20 years away. And if we can crack fusion energy, anyway, let's not go into fusion. There's applied physics, materials, chemists, so all the new battery chemistry that we need to power our new electric cars and everything, that comes from more from the science side of things than from the engineering side of things. So yeah, we need mathematicians, construction people, project management, installation and maintenance techs. Somebody's got to build and maintain all this thing. Heck, we even need accountants and lawyers. What do we need accountants for? Well, and as I said, it costs money to produce all this stuff. How do we know that we're actually producing something that's going to get more energy out than we put in to produce? It's actually quite a complicated thing to account for, and there's much argument currently over whether or not solar panels can pay back, whether or not wind can pay back the energy required to build those things than you get back out of it. And there's a lot of research and number crunching that needs to go into that. And yeah, I don't know, we might need lawyers for something. I don't know. So what are some of the big innovations that we need? Superconductors. If somebody can crack room temperature superconductors, instant Nobel Prize for you. Fortune and glory, kid. New high density battery chemistries, because a lot of the problem is we just can't store enough energy in the batteries these days. Even though it gets better every year, it's getting like, a few percent better every year. There's no big steps in battery chemistry technology. It seems to be a pretty linear kind of growth. So if somebody can come along and go, whoop, here's some new battery chemistry that's fantastic, then, well, once again, fortune and glory, kid. Other storage solutions, molten salt, flywheels, compressed gas, gravity, and there's lots of research going on. I mentioned molten salt before, but gravity-based systems, for example, dams. What you can do is you can actually pump water up into a dam. So you can use the energy from, say, solar or wind during the day to pump water up back into a dam, and then that dam stores the energy as potential energy, and then you release it, and then just use hydro hydro to generate the power. And there's many other different ways to do that. You can physically lift large weights up, and then during the day use the energy to lift them up, and then slowly fall overnight so you can extract the energy out. So there's lots of those alternative storage solutions, because storage is one of the big things, because solar and wind, of course, don't produce energy at night or when the wind's not turning. So for it to be really useful, we need, as I said, baseload storage solutions there. Big deal. Then power electronics. If you can produce a much more efficient, invent some new technology, much more efficient converters and things like that, that's really a big deal. I won't go into details. And as I said, smart grid technology, the grid needs to be smart. It needs to be, if we can shuffle energy, switch energy around, move it around, that's going to be a more valuable and more reliable grid than if it's just some dumb grid. So there's software required there, artificial intelligence systems, blockchain, which is Bitcoin and all that. Somebody's got to account for all the energy flowing everywhere. So there's lots of research going in that sort of area. But the thing is, for sustainable energy to be a big deal, we don't need these huge innovations. They're nice if they come along, but the reason that the renewable energy industry is getting bigger and bigger over time, as I said, linear growth, lots of small changes every year. The battery chemistry gets 2% better or something like that. Efficiency in converters gets a couple of percent better. So, if you can come along and you can invent a new battery chemistry that's a few percent better or 5% better, right? That's worth billions of dollars. Once again, fortune and glory for somebody who can just make these little incremental improvements. And wind turbines, for example, if you're a mechanical engineer and you come up with some new ultra efficient blade design, that's 5 or 10% better. Doesn't sound like much, but that can make a massive improvement worldwide. That can really be a game changer. So yeah, just small things. Even software engineers, grid solutions, switching the energy around so that it's much better utilized and stuff like that. All these sorts of things can have big impacts. Just small changes, when you implement them globally, makes a big difference. Woo! All right. I asked on my I run an engineering forum, and I asked on there, I told them I was going to give this talk, and I said, should I mention this? And half the people said, yeah, do it, Dave. They need to know about this. These young kids need to know about this. The others said, no, don't mention it because it's too negative and you only want to encourage them. You don't want to discourage them from getting these radical ideas and things like that are going to save the world. Well, guess which one I'm going to pick? It's critical thinking time. I think you need to know about this. So I'm going to play you a short video clip, and there's going to be questions at the end. So watch carefully. Because unfortunately, in the renewable energy industry, there are some really fundamentally stupid ideas, and there's scams, and there's all sorts of things going on. Anyway, watch this video. Let me know what you think of this renewable energy idea.
Solar Freak'n Roadways.
What are they?
They're Solar Freak'n Roadways. What do they want from me? Well, they're Solar Freak'n Roadways. Okay, so actually this time, what is it? It's technology that replaces all roadways, parking lots, sidewalks, driveways, tarmacs, bike paths, and outdoor recreation surfaces with solar panels. And not just lifeless, boring solar panels. Smart, microprocessing, interlocking, hexagonal solar units. No more useless asphalt and concrete just sitting there baking in the sun, needing to be repaved and filling with potholes that ruin your axle alignment on your sweet ride, bro. These are intelligent solar panels. Replaced a panel at a time if damaged or malfunctioning. They're covered with a new tempered glass material that has been designed and tested to meet all impact, load, and traction requirements. Oh, and did I mention that they're also solar panels? They generate electricity, they generate capital, they pay for themselves, and they keep paying more because we're not gonna run out of sun for like 15 billion years. That lowers the cost of energy, unlike those bills in the mail that keep going up, and it's clean energy. Everyone can theoretically drive an electric car with no pollution and a minimal carbon footprint. Can you imagine how good our cities would smell? How much healthier we'd all be? For those in the north, the panels use energy they collect to power elements to keep the surface temperature a few degrees above freezing. They're heated. No more ice and snow on roads causing traffic delays, accidents, and injury. No more shoveling your driveway and sidewalk. No salt corroding your car or wasting tax money on snow removal. And you can ride your bike or drive your motorcycle all year round. Whoa! Every panel has a series of LED lights on the circuit board that can be programmed to make landscape designs, warning signs, parking lot configurations, whatever. These roads never have to have lanes repainted, just reprogrammed to whatever we choose or whatever works best. Imagine a highway road lighting up ahead of you. How much safer it would be to drive at night. There'd be improved visibility for pilots landing on solar landing strips. Imagine walking onto a solar recreation court and choosing a sports configuration. Want to play basketball? Cool. Kids want to play hopscotch and Foursquare? Awesome. Ball hockey? Done. And with LED lights under your feet, it's gonna look like freaking Tron out there. But real, because this is the real world. Whoa. But these panels are also pressure sensitive, so they can detect when large debris like branches or boulders have fallen onto the road, or if an animal is crossing. It can warn drivers with LED text to slow down for an obstruction. And it pays for itself. They're Solar Freak'n Roadways. I have concerns about the future. Is this thing even possible? I told you, yes.
There you go. Solar roadways. Hands up if you think this sounds like a good idea. On the surface, it sounds like an absolutely fantastic idea. All these roads out there, we're just driving all this unused, like this space that's going to waste. If you can, instead of making concrete or bitumen roads, why not replace them with solar panels? Why not drive on these solar panels? Well, this thing's actually real, and it actually raised over $4 million for this. And it was a crowdfunding campaign, and then it actually spread around the world. A lot of other people took up this idea and did it. In China, in the US, that's the $4 million one with these little disco lights here. It's anyway. France did a big trial. Netherlands did a big trial. China did a big trial. Who can think of any issues with this? Because it sounds like a great idea and it's going to save the planet. Just convert all our roads to solar panels, right? Who can think of anything that might actually be fundamentally wrong with this idea? Right, cars. The sun can't hit the solar panel. Cars. Dirt, grime, driving on glass. You think that might be a problem? Well, as it turns out, yeah, it's a fundamentally stupid idea, and all of these trials failed exactly as engineers like myself predicted they would. In fact, they were worse than what we predicted. So, yeah, you do not drive on solar panels. So what are some of the solutions? Well, you put them on rooftops. You put them over cover car parks with them first. So once you've done, so don't think about this idea like solar roadways. So what is a good idea? Hey, you know, the solar roadways is a good idea. How do you do it? Well, let's play another short clip. This is how you do it. This is a 32-kilometer solar bike lane in the middle of a road in South Korea. And they've nailed it. Look, it's fantastic. There's no cars driving on it. They're clean. They're probably going to last for 20 years. They're not going to degrade. There's not going to get dirt and grime on them. They're not going to get physically damaged. Absolutely beautiful solution. So, yeah, some ideas are just fundamentally dumb. So next time some hipster tells you that, oh, this new renewable technology is going to save the world, man, put on your thinking cap and think whether or not it really is a good idea, or whether or not they're just jumping on the renewable energy bandwagon. Anyway, critical thinking, it's important. So yeah, don't just go la-la over every single idea that comes along, because here's my favorite quote of all time from Carl Sagan: "It pays to keep an open mind, but not so open-minded that your brains fall out." All right? So that's almost it. This is my last slide. I'm talking about, I've heard that you guys are going to be making a solar hot water system in the next week. Awesome project. As it so happens, I've actually designed and built and installed my own solar air heater, which is why? Because I'm a nerd, you know. Yeah. And it's very similar. Solar air heaters work very similar to solar water heaters. You just put a big panel heatsink on top of your roof, which absorbs the solar insolation coming from the sun, not insolation, which is the amount of energy that hits per square meter. If you want to know, it's 1,000 watts per square meter, roughly, coming from the sun. That's what we have. So if you have a 100% efficient solar panel, for example, and it's 1 square meter, you'll get 1,000 watts of power out of that. So yeah. And anyway, that's what's available if you have 100% conversion. So you heat up these things and you have either water or air, in this particular case, running through pipes in there. You pump it through, it absorbs that energy from the sun and then pumps it through either air or water into your shower or into your home. You pump air around. Now, I love these sorts of projects because there's so many things that you can measure and analyze on this sort of stuff. And here's just some graphs that I got of like the air temperature of the collector plate versus the one in the room versus the outside air temperature. And you can look at all the differential temperatures and stuff like that. And it's really quite fun to actually analyze and plot this particular case. And if you're wondering what happened with my solar air heater, I don't have it anymore because it was just a trial. And it really just wasn't big enough. It wasn't efficient enough because to get so efficient, practical solar and water air heaters, you need to pump around X amount of energy. And you can do the calculations on these sorts of stuff. It's just, high school physics type calculations to be able to calculate how much volume of water or how much volume of air that you need, how much energy input you have, and how much that will raise the temperature of your room, assuming that there's no air leaks in your room and stuff like that. So anyway, solar air heaters, solar hot water systems, nice and fun. So I'm sure you're going to have a great deal of fun over the next week actually building, designing and building one of those. So that's it. That's it from me. Thank you very much.